Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore the fundamentals of Amazon Step Functions, a powerful orchestration service that lets you coordinate AWS services and custom applications using visual workflows. Whether you're building data pipelines, automating serverless applications, or managing complex enterprise processes, Step Functions offers a robust, scalable, and reliable way to handle stateful logic with ease. Let's get started. Amazon Step Functions is a serverless orchestration service that makes it easy to coordinate components of distributed applications and microservices using workflows. At its core, Step Functions helps you break down complex business logic into discrete steps, allowing you to manage them in a clear, reliable, and scalable way, all without provisioning or managing servers. Step Functions offers deep native integration with a wide range of AWS services, from Lambda and DynamoDB to ECS, Glue, SageMaker, and more. You can trigger actions, pass data between services, and manage execution states seamlessly, reducing the overhead of stitching services together manually. One of the standout features of Step Functions is its intuitive visual workflow modeling. You can design and view your application's flow in the AWS console, making it easy to understand how data moves and how each step interacts. Workflows in Step Functions are defined using the Amazon States language, a structured JSON-based format that allows you to declare states, transitions, conditions, parallelism, and input-output transformations. This gives you full control over how your application logic is orchestrated, with support for complex branching and looping logic. There are two execution modes to choose from: Standard and Express. Standard workflows are ideal for long-running, durable processes, while Express workflows are optimized for high-throughput, short-duration tasks. Reliability is built in from the start. Step Functions natively supports robust error handling with automatic retries, catch and recovery blocks, timeouts, and fallback states. These capabilities significantly reduce the need for boilerplate code and make your workflows resilient to transient failures across services. Finally, Step Functions supports both code-first and visual-first development. You can define workflows directly in the console, or manage them programmatically using infrastructure as code tools like AWS CDK, CloudFormation, or the SDKs. Amazon Step Functions offers a range of powerful benefits that make it an essential service for orchestrating distributed applications on AWS. At the heart of its value is the ability to simplify complex workflows. Instead of embedding control logic across multiple services or writing spaghetti code to manage execution flow, Step Functions lets you define your logic cleanly and declaratively. This makes your architecture easier to understand, maintain, and evolve over time. Development becomes significantly faster. With Step Functions, you can visually prototype and deploy workflows quickly. There's no need to write glue code to connect AWS services. It's all handled natively through the workflow definition. This accelerates delivery, especially when you're iterating on business logic or building event-driven systems. Debugging and operational visibility are also greatly enhanced. The AWS console provides a real-time visual map of each workflow execution, showing every step, its inputs and outputs, and the status. This makes it incredibly easy to trace failures, monitor long-running processes, or audit historical executions. Operational overhead is reduced dramatically. As a fully managed service, Step Functions handles execution, scaling, and state management for you. There's no need to provision servers, manage workers, or build orchestration engines. AWS takes care of it behind the scenes. Step Functions excels at microservice coordination. It can seamlessly orchestrate services like AWS Lambda, ECS, SQS, and SNS, allowing you to build complex service meshes or back-end processes that are event-driven, loosely coupled, and fault-tolerant. Lastly, it promotes modularity and reusability. By decoupling business logic into discrete stateless functions, Step Functions encourages clean architectural patterns where individual components can be reused across multiple workflows and teams. To effectively work with Amazon Step Functions, it's important to understand its core components, the building blocks that define how your workflows are structured and executed. At the top level, everything begins with a state machine. This is the central resource that represents your entire workflow. Defined using Amazon States Language, or ASL, the state machine specifies the sequence of steps, transitions, and conditions that govern your application logic. Within a state machine, the workflow is composed of multiple states. Each state performs a distinct function. It might run a task, make a decision, wait for a period, or simply pass data. States are connected to each other through transitions, and the workflow progresses by moving from one state to the next. One of the most common types of states is the task state. This is where actual work gets done, whether that's invoking a Lambda function or triggering a batch job in ECS or Glue. Each task can return output that flows into the next state, making it easy to pass results downstream. To add intelligence to the flow, Step Functions provides the choice state. This allows you to introduce conditional logic, so your workflow can take different execution paths based on the data at runtime. For workloads that can benefit from parallelism, the parallel state comes into play. This state lets you run multiple branches of execution simultaneously. For example, processing multiple datasets or calling multiple APIs concurrently. Once all branches finish, the workflow continues to the next step. There are also utility states that help manage the flow. The pass state simply passes its input to the next state, while the wait state introduces a time delay, allowing you to pause execution for a fixed duration or until a specific timestamp. And the succeed and fail states are used to explicitly end a workflow, either successfully or with an error. Finally, two critical directives, start at and end, define the entry point and exit of your workflow. Start at determines where execution begins, while end, true, designates the conclusion of a particular branch or the entire workflow. Amazon States Language, or ASL, is the core language used to define workflows in AWS Step Functions. It's a JSON-based, domain-specific language designed to describe state machines in a clear, structured, and machine-readable way. While it may look like simple JSON, ASL is extremely powerful, allowing you to model both simple sequences and highly complex workflows with conditions, parallelism, and error handling built right in. At its core, ASL lets you define a series of states, each of which performs a function, such as executing a task, evaluating a condition, waiting for a set time, or terminating a process. These states are connected by transitions, and the workflow begins at the state specified in the Start At field. Each branch, or the overall workflow, ends when a state includes end true. ASL supports a rich variety of state types, including task for executing a function or service call, choice for conditional branching, parallel for concurrent processing, and pass, wait, succeed, and fail for utility and control flow. These state types let you model real-world business logic with precision. ASL also supports data transformation paths using input path, result path, and output path. These allow you to manipulate the data passed between states, selecting specific input, modifying results, and shaping output dynamically. Another key capability is ASL's integration with AWS services. Using the resource field, you can directly invoke AWS services like Lambda, DynamoDB, ECS, Glue, and Step Functions' own API integrations, simplifying the coordination of distributed components. One of the most powerful aspects of ASL is its built-in support for error handling. Each state can include retry, catch, and timeout seconds fields, which allow you to gracefully handle failures and recover without writing extra code. Overall, ASL gives you full control over the behavior, structure, and data flow of your workflows. By learning how to write and read ASL definitions, you unlock the ability to model and manage sophisticated automation scenarios directly within AWS. Here is an illustration of a use case for step functions. In modern data-driven applications, ETL plays a vital role in converting raw data into actionable insights. Whether you're cleaning messy logs, enriching user data, or joining multiple sources for analytics, ETL is foundational to every data pipeline. With AWS Step Functions, you can orchestrate complex ETL workflows that are event-driven, resilient, and scalable. A major advantage is the ability to run multiple ETL jobs in parallel, each triggered only when its corresponding dataset is ready, even if those datasets become available at different times. Let's take a real-world example. Imagine you're working with two datasets, one for sales and another for marketing, each processed by separate AWS Glue jobs. These jobs can run independently, and Step Functions manages their coordination. When both are done, a third ETL job merges the outputs to create a unified, combined dataset ready for analytics or reporting. The workflow starts on a schedule, but it doesn't blindly run the ETL jobs. Instead, it listens for specific events. Thanks to Amazon EventBridge, we can watch for file uploads to an Amazon S3 bucket. When the sales or marketing dataset is uploaded, the corresponding job, process sales data, or process marketing data, is triggered automatically. Step Functions orchestrates this seamlessly, waiting for dependencies to complete, handling retries if needed, and ensuring that each stage of the pipeline progresses only when it should. It's serverless, reactive, and gives you full visibility into each ETL stage. By using Step Functions to coordinate ETL workflows, you can create robust, modular pipelines that are easier to manage and scale, with less glue code and more focus on data transformation. AWS Step Functions offers two distinct workflow types, and first, we'll explore standard workflows. These are designed for long-running, durable, and enterprise-grade workflows that may span minutes, hours, or even days. Whether you're orchestrating a complex order fulfillment system, running a multi-stage data processing pipeline, or handling approval-based business workflows, standard workflows are built to handle it all. One of their biggest strengths is exactly once execution semantics. This means every step in your workflow is guaranteed to run just once, even if there are retries due to transient failures or timeouts. This level of consistency is critical for workflows where duplicate execution could lead to data integrity issues or financial inaccuracies. Another major advantage is persistence of execution history. Each run of a standard workflow is logged and stored for up to 90 days. You get a full visual trace of every state, transition, input, output, and any errors that occurred. This is incredibly valuable for auditing, debugging, and compliance, especially in regulated industries. Standard workflows are also highly fault-tolerant and durable. They're designed to automatically recover from underlying infrastructure issues and can span multiple availability zones and even regions, offering resilience for mission-critical systems. You're billed based on state transitions, not time, which gives you fine-grained control over cost. Each time your workflow moves from one state to another, it counts as a transition. For long-running processes with fewer steps, this model can be especially economical. Another standout feature is support for human interaction via task tokens. Standard workflows can pause execution and wait for a human to complete a task, like an approval or manual data input, before continuing. This makes them ideal for use cases that require manual intervention along the way. While standard workflows are built for long-running, durable applications, AWS Step Functions also offers express workflows, a faster, leaner alternative optimized for high-volume, short-duration tasks. These workflows are ideal when speed and scalability matter most. Think real-time data processing, microservice orchestration, or stream-based event handling. Express workflows are designed for high-throughput workloads, capable of supporting thousands of workflow executions per second. They're an excellent fit for scenarios like processing messages from Amazon SQS, reacting to events from EventBridge, or orchestrating short Lambda-based microservices. One of their key characteristics is at least once execution semantics. Unlike standard workflows, which guarantee exactly once execution, express workflows prioritize speed and scale. This means tasks may run more than once under certain conditions, making them well-suited for idempotent operations where duplicate execution won't cause problems. Express workflows are event-driven and highly responsive, launching almost instantaneously with minimal overhead. They can run for up to 5 minutes per execution, making them perfect for lightweight, fast processing use cases. When it comes to observability, execution history isn't retained in Step Functions' Visual Console, but logs can be streamed to Amazon CloudWatch Logs or AWS X-Ray. This still provides full visibility into each step, duration, and any errors while keeping the system lightweight and performant. The pricing model is also different. Instead of billing per state transition, express workflows are priced based on duration and memory usage, very similar to how AWS Lambda is built. This allows you to predict and control costs for short-lived, high-frequency workflows more easily. Together, standard and express workflows give you the flexibility to choose the right execution model for your application, whether it's long-running and durable or high-speed and event-driven. One of the key strengths of AWS Step Functions is its powerful and flexible approach to error handling and retries, allowing you to build workflows that are not only robust but also self-healing. Each state in a Step Functions workflow can include a built-in retry mechanism. With just a few lines of JSON, you can configure how many times to retry a failed step, how long to wait between retries, and how aggressively to back off using exponential delay. This allows you to gracefully handle transient issues without writing any retry logic in your application code. When retries are exhausted or a non-recoverable error occurs, Step Functions provides catch blocks for graceful failure handling. These allow you to direct the workflow to a fallback state, such as sending an alert, logging the issue, or triggering a compensation task. Step Functions also supports fine-grained error matching. You can specify exact AWS error types like lambda.serviceException or broader categories like states.timeout, or even use a wildcard to apply retry and catch logic to any kind of failure. This gives you the flexibility to tailor error responses based on the nature of the failure. Each state can also define a timeout seconds value, helping prevent indefinite hangs. If a task exceeds this timeout, it fails automatically, triggering any retry or catch logic you've defined. In cases where the workflow must explicitly terminate due to a critical failure, you can use the fail state to stop execution in a controlled way, optionally passing along custom error messages for context and diagnostics. On the other hand, even after recovering from an error, workflows can continue executing normally and still reach a succeed state, ensuring that transient or non-fatal issues don't derail your entire process. Finally, the visual debugger in the Step Functions console gives you a complete view of execution paths, retries, errors, and recovery flows, making it easier than ever to identify what went wrong and why. AWS Step Functions offers an incredibly intuitive and powerful tool for building workflows, the Workflow Studio. This visual design interface allows you to create, modify, and manage state machines using a drag-and-drop canvas without writing any code. Workflow Studio is designed with both developers and solution architects in mind. It provides a low-code environment that accelerates the development process while still maintaining the flexibility and power of Amazon States language behind the scenes. You can focus on business logic and orchestration without worrying about syntax errors or deeply nested JSON. On the left-hand panel, you'll find a rich library of pre-built task types and service integrations. These include AWS SDK integrations for services like DynamoDB, SNS, SQS, Lambda, Step Functions, nested workflows, and more. Simply drag a task onto the canvas and configure it using built-in forms. No manual coding required. Each block on the canvas represents a state in your workflow. You can visually wire together sequences, add parallel branches, introduce error handling paths, and even build retry logic, all by clicking and connecting components. The right panel gives you access to configuration options, allowing you to customize input and output paths, parameters, error catchers, and result selectors. What makes Workflow Studio even more powerful is the live ASL preview. As you build visually, the underlying JSON code updates in real time. This helps bridge the gap between visual design and infrastructure as code, making it easy to copy the definition for CI/CD pipelines or version control. Whether you're prototyping a simple two-step process or orchestrating a complex, multi-branch workflow, Workflow Studio lets you design, test, and iterate faster, with greater confidence and clarity. Let's now take a closer look at the AWS Step Functions visual editor. This part of the workflow is responsible for storing account information in DynamoDB and sending a confirmation email via Amazon SNS. We begin by adding a DynamoDB put item task, shown here as step 1. This task will write a new item, in this case the user's account information, directly into a DynamoDB table. What makes this step especially powerful is that it doesn't require any Lambda function to handle the operation. Step Functions integrates directly with DynamoDB through the AWS SDK integration, so we get serverless orchestration without additional code or compute overhead. Next, we add an SNS publish task, as shown in step 2. This task sends an email notification to confirm the successful creation of the account. What's convenient is that we already created a similar task earlier in the error handling path. So instead of configuring it from scratch, we can simply duplicate that SNS state, drag it into our happy path, and update the message payload. The underlying configuration remains largely the same topic ARN, same structure, just a different success message. Then, in step 4, we configure the API parameters for the DynamoDB put item action. This includes specifying the table name, defining the key and attribute values to be written, and making sure the input path maps correctly to the request payload. Step Functions makes this configuration intuitive with structured forms and built-in validation. You can see exactly how your workflow flows from one step to the next, modify tasks by simply clicking and dragging, and reuse components like the SNS publish task with minimal effort. This reduces errors, saves time, and gives you a clean, declarative view of your business logic. When building serverless workflows in AWS Step Functions, security and compliance are not just afterthoughts. They're foundational. At the core is IAM-based access control. You can define fine-grained permissions to specify exactly who or what can create, update, or execute a state machine. This allows for strict separation of duties and ensures that only authorized entities can interact with your workflows. For more advanced scenarios, Step Functions supports resource-based policies, allowing secure cross-account access. This is especially useful in large organizations or multi-account setups where central orchestration needs to interact with workloads in other accounts. Data security is also built in. All workflow inputs, outputs, and transitions are encrypted in transit using TLS and encrypted at rest using KMS. You can use AWS managed keys or bring your own customer managed keys for tighter control and compliance alignment. Step Functions also supports integration with VPCs and AWS Private Link, which means you can keep data exchanges entirely within the AWS network and away from the public internet. Each state machine runs under a scoped IAM execution role, which defines exactly what downstream AWS services it can invoke. This minimizes the blast radius of any potential misconfigurations or compromises. Every interaction with Step Functions, from execution starts to failures, is logged in AWS CloudTrail. This provides a complete audit trail for traceability and compliance, enabling you to monitor who did what, when, and from where. Finally, from a compliance standpoint, AWS Step Functions meets a wide range of industry and regulatory standards, including SOC, HIPAA, PCI DSS, ISO 27001, and FedRAMP. This allows you to build workflows that not only scale, but also comply with the requirements of even the most regulated industries. Understanding the pricing model for AWS Step Functions is key to optimizing your workflows, both for performance and cost efficiency. AWS provides two distinct pricing approaches based on the workflow type. First, standard workflows. These are priced based on state transitions, that is, each time your workflow moves from one state to another. AWS charges a fixed rate per 1,000 state transitions, making it easy to estimate and manage costs. This model is ideal for longer-running, durable workflows where the total number of transitions is moderate and predictable. On the other hand, express workflows follow a duration-based billing model. Pricing is calculated using GB seconds by multiplying execution time by memory used. This makes express workflows a better fit for short-lived, high-throughput workloads. You're essentially billed for the actual compute resources consumed. A big plus is the AWS free tier, which gives you 4,000 free state transitions per month for standard workflows. This is perfect for testing, learning, or even deploying small production workflows without incurring additional costs. For visibility into usage and cost, Step Functions integrates tightly with Amazon CloudWatch metrics. You can monitor how many transitions or executions are happening, track success and failure rates, and get real-time data on performance, all of which helps in forecasting and controlling your spending. And here's another important point. AWS doesn't charge extra for service integrations within Step Functions. Whether you're invoking a Lambda function, a DynamoDB operation, or an ECS task, you only pay for the execution of those services, not for the act of calling them through Step Functions. Ultimately, Step Functions offers a scalable, pay-as-you-go pricing model that allows you to align your architecture choices with cost goals. By selecting the right workflow type and designing with cost awareness, you can build robust, event-driven applications that are both powerful and budget-conscious. Monitoring is a critical part of any production-grade workflow, and AWS Step Functions offers a rich set of tools to help you track, debug, and optimize your state machines with precision. The first and most immediate tool, Execution History, available right in the AWS Management Console. It provides a visual, step-by-step breakdown of every execution, showing each state, its input and output, and whether it succeeded or failed. Beyond the console, Step Functions emits native Amazon CloudWatch metrics for core lifecycle events. These include executions started, executions succeeded, executions failed, executions timed out, and execution time. To get a more granular view of each execution, you can enable CloudWatch logs. With logging turned on, you get detailed data on each state, including inputs, outputs, retries, and failure reasons. This log-level visibility is invaluable for debugging and for meeting auditing requirements. For distributed systems, where Step Functions orchestrates multiple AWS services, AWS X-Ray can be integrated to trace requests end-to-end. X-Ray gives you deep visibility into the latency and response patterns of each service call, helping identify bottlenecks and optimize workflow performance. From a compliance and governance perspective, AWS CloudTrail plays a key role. Every API call made to Step Functions, whether it's creating a state machine, updating a definition, or starting an execution, is recorded in CloudTrail. Another powerful feature is error cause and message propagation. When a state fails, you can capture the cause and pass it along downstream. This not only aids in debugging, but also allows you to implement intelligent error handling flows that adapt based on the type or source of failure. And for broader observability, Step Functions integrates easily with visualization tools like CloudWatch dashboards, Amazon QuickSight, or even third-party platforms. This makes it easy to build unified operational views across services and stakeholders. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.